Yeah, so if we have a rectangle and we cut it in half, we get triangles, don't we? So when we say half base times height, what do we actually mean? It's a half
square.
Well, no. Half times base times there's something else that needs to go in height. Okay. Not length, no. It's important that it comes from a rectangle, because actually we get the same sort of idea if we go from a different...
Oh, length times width?
What shape have I got here? What's that called?
Rhombus.
No.
Parallelogram.
That's a parallelogram.
What's a
Okay.
rhombus?
Rhombus is a parallelogram, all sides at the same length. Like a square to a rectangle, a rhombus is to a parallelogram.
Do you mind if I get a meeting?
So, height. So if I've got this triangle, this is my triangle, right? This would be considered the base, this would be considered the height, yeah? Now, if I take a parallelogram and cut it in half, I still get two triangles, right?
Mm-hmm.
That's where the half bit comes in. Just ask my M2s to go away over homework over the weekend and figure out where the half comes from. So is this the base of the triangle? Where's the height?
From the top or the one of the corners and
Yeah.
down, straight down. So
Okay.
90 degree angle.
That's what we're looking for, isn't it? So the word that goes into the word height is the perpendicular height. Okay? Which is why we start talking about it with rectangle. Are you with us, Zoe? Are you making any notes? Or you don't need to? No? So we've got our perpendicular height. And with a rectangle, that's nice and easy because a rectangle has 90-degree angles. But a parallelogram doesn't have 90-degree angles. It will have other angles. Okay? So, what does that lead us to? Well, that leads us to the situation where we've had in the past, where if your teacher says, work out the area of this triangle, right? Let's say units are in centimeters. What the area of that triangle?
7.5.
Because we do 3 times 5, divide that by 2, and we get 7.5 square centimeters. Okay? That's easy, right? But then your teacher then says, right, here is a different triangle. And they say that this is 8 and this is 5. Okay. Let's say this is 7, right, centimeters. And they ask you to work out the area of that triangle.
I'll get my formula booklets. I think I remember this formula somewhere.
Well, it was at the top of the page, so. Nick, what?
I would just, you'd cut it in half from the middle of the base to the point.
Middle of the base to the point. Okay, so middle of the base. So I've drawn it so that the middle of the base to the point. Let's go back there. What's the trouble with that? It's not equal, is it? Because that's 7 and that's 5. So that doesn't help me.
Well, if it's in centimeters, I guess then.
Yes, or an isosceles. Yeah. It's good that you're thinking about that. Yeah, there are times when you could draw straight down the middle. But this is a what type of triangle? Scalene triangle.
Even
Yeah.
if you drew down the middle, you could still figure it out, right?
No.
Like Pythagorean theorem. I mean, not.
Okay, well, no, let's talk this through. So if we were going to, because it is important that we go through this, if I drop that down there and I do make 90 degrees, I think what you were doing, you realize pretty quickly, what's the common mistake? Is to think, especially with my diagram, that that's 4 and 4.
Yeah.
Cutting up. How do I know it's not cut in 4? 4 and 4.
The length of 5 and 7.
Exactly. So if I wanted Pythagoras' theorem to work that out, I can't, can I? Because I would need to know what those were, what that split is. And do I know what that split is? Is there any way of working any of this out?
I believe there is. Momentum.
Well, you might be pushing ahead. So before we start getting on to cosine rule, which is what we use for the boxes, yeah? So in this case, I could use the cosine rule to work out a what? I've got all the lengths. An angle. Yeah?
Yes, that's what I was looking
Yeah. All right. So, but what we'll do, let's say instead, I'm going to get rid of the 7 just so that I'm not going to cause myself issues. Let's say that I've got a 5 and an 8. I don't know what this is, and I don't know what the height is. I've got a base of a triangle. I've got I want to know the perpendicular height. And let's say I'm given this angle, right? So obviously you've already figured out that the next stage will be what if we're not given the angle. But let's say I give you this angle, and let's say, what do you want it to be, Zoe? 32. I wouldn't have done that. It's the hardest one you could have possibly picked. All right. What can we do now? No. That's all the information I've given you. What can we work out?
With trig ratio to find out the height.
So we can work out the height using trigonometry now, can't we? Because if I ignore this half, I now don't need to know the split, do I? Because what trig ratio am I going to use? How can I work out? So let's call question mark. That's a bit bad notation, isn't it? Question marks, we shouldn't use. Let's call it height. How can I work out the height? What do you reckon, Ashton?
Well, you would use sine.
Yeah.
Like,
So sine of 32 degrees is equal to h divided by 5, and therefore h is equal to 5 times the sine of 32. Okay? All right. So let's now put that into my formula that I've got. A is 1/2 times the base times the height. So let's put it in, but with numbers that I now know. So I've got the area will be 1/2 times, what's the base? What's the height?
Oh,
Okay, put lots of multiplication signs in. All right. Have I got everything I need to know now to work out the area? Okay. Yep.
Now we have the formula that you
We do, don't we? We have the formula that I gave you.
A, B,
Yeah, we have 1/2 multiplied by A multiplied by B multiplied by sine of the angle. But there is something that's important, isn't there? Where are A and B? Right?
B is the height, but not the what's it called? It's not the perpendicular height. Or it's one of the lengths. B is one of the lengths.
One of the lengths, but we've got to be careful, haven't we? Because what do you notice? A was that side,
B is the height.
B is that one, and the angle. So, just like when we talked about cosine rule, we must have two sides and do you remember being called the included angle? What do I mean by it being the included angle?
the angle created by the two sides.
Yeah, so the two sides that I know must be the ones that create the angle that I know. Does that make sense?
Yeah.
So, for instance, it's not going to work out. I can always come back to this if you want to make notes, but let's say I have a different triangle, right? And I tell you that this is 9 and this is 13 and this angle is 73. Is the area 1/2 times 9 times 13 multiplied by sine of 73? Yes or no?
No.
Why not? Greg?
Because it does not have two sides in the included angle.
Exactly. Right? These are the two sides that I know. Which angle would I need to know?
That it creates.
One that it creates.
Wouldn't that have to be 90 in order for that to be a sine, and then it can't be 90? You know what I mean? Like, wouldn't it have to be a right angle triangle
Why?
in order for you to do that? The sine thing?
No. Remember, we worked out by using this, but once we've got our formula, we don't need that, do we? This whole bit gives me that length, but I don't need to refer to it separately. All right? All right. So, we can use it when we've got two sides and the included angle. We can't use it. God's sake, guys, come on. He's sharpening a pencil, Nick, and that is what your biggest concern is. No? You've got no notes at the moment.
Unusable. I'm sorry.
Guys, so is that all right? Is the formula good for working? So if I get you to look at practice 2 on page 186 then, all right? Have a go. Again, the first couple of questions are the simpler ones, just applying the formula, and then you get to your problem solving ones, okay? What we do though is we want to move on relatively quickly, like minimum by next lesson, onto the stuff with the arcs and parallelograms and things like that, okay? So page 186, using that formula. Do you have it in your formula booklet?
Yes.
Yeah, so there's not even any need to remember it.